Everyone. In online lecture, we learn theory of linear correlation. Now we are going to start learn formula of this chapter. In this chapter, there are two types of correlation. Number one is right. Number one is Karl Pearson's correlation coefficient, or we can write Karl Pearson's method. Karl Pearson's method. In this method, there are total 5 to 7 formulas. Number 1, when covariance of xy, sx and sy are given. Okay, then R is equals to formula is covariance x comma y divided by sx into sy. Okay, this is first formula was given by Karl Pearson, where wait covariance xy is equals to sigma x minus x bar into y minus y bar upon n. Okay, now formula number 2. Okay, second formula, we are putting value of covariance xy in first equation, putting value of covariance xy in first formula. Okay, and we will get our second formula. R is equals to, see, instead of covariance xy we have to put this one. We will get sigma x minus x bar into y minus y bar upon n. This is value of covariance xy into what left, sx into sy. Okay, where sx is equals to standard deviation of x, sigma x minus x bar whole square upon n, and sy equals to under root of sigma y minus y bar whole square upon n. Okay, this is sx and sy. Okay, now we are putting value of sx and sy in our second equation, and we will get our third formula. Okay, putting value of sx and sy in formula number 2. Okay, see, this is our formula number 2, and we have to put values of sx and sy. See what happened. R equal to sigma x minus x bar into y minus y bar upon n. About to as it is Now sx equals to what? under root sigma x minus x bar whole square upon n into under root sigma y minus y bar whole square upon n and આપણે એક જ under root માં લખીએ sigma y minus y bar whole square upon n. Okay, હવે ખાસ ધ્યાન અહીંયા. Therefore r equal to sigma x minus x bar into y minus y bar divided by n. See, n into n, n into n. What is given in under root 1 upon n માની લઈએ આપણે upon 1 upon n. Okay, અને આપણે અત્યારે કઈ નથી ગણતા એટલે 1 upon n into 1 upon n is equals to what? Under root of 1 upon n square. અને under root ની બહાર લઈએ તો શું આવે? 1 upon n means denominator માં n આવશે. સમજાણું? n into n is equals to n square. Under root ની બહાર આવે તો it becomes n. તો અહીંયા n આવશે into under root of sigma x minus x bar whole square into ચાલો એક જ under root માં આપણે લખ્યું છે એટલે એમને રહેવા દઈએ sigma y minus y bar whole square. Okay, here n should be cancelled out. Therefore r equal to what left? R equal to sigma x minus x bar into y minus y bar upon under root of sigma x minus x bar whole square into under root of sigma y minus y bar whole square. This is our formula number 3. But remember that this formula means formula number 3. This formula use only when x bar and y bar are integer. Okay, so we have to use this formula only when x bar and y bar are integer. એટલે કે x bar y bar પૂર્ણાંક હોય તો જ આનો યુઝ કરવાનો, અધરવાઇઝ આનો યુઝ ક્યાંય તમારે કરવાનો થતો નથી. Okay, now formula number 4. Formula 2 can also be written as, okay, see what is our formula 2? This is our formula 2. This formula can also be written as, if we expand second formula we will get, અત્યારે આપણે એટલો બધો ટાઈમ નથી એટલે expand નથી કરતા, but if we expand this formula we will get r is equals to sigma x5, sorry, sigma xy minus n x bar y bar upon n into sx into sy. Okay, now see the formula number 2. Same છે n sx sy denominator, ખાલી આપણે ન્યુમરેટર એક્સપેન્ડ કરીએ તો આપણને ફોર્મ્યુલા નંબર 4 મળશે. Okay, now formula number 5. Formula number 5, this is called direct method. Direct method. Okay, use this formula when observations of x and y are very small. વેરી સ્મોલ એટલે ખૂબ નાના હોવા જોઈએ. કેટલા નાના એનું કોઈ ડેફિનેશન નથી, પણ હું અહીંયા એમ લખું છું 20 or less. 20 કે તેથી નાના હોય ત્યારે આપણે આ મેથડનો યુઝ કરશું. r equals to n sigma xy minus sigma x into sigma y upon under root n sigma x square minus sigma x whole square. Okay. And under root of n sigma y square minus sigma y whole square. This is formula of direct method. It can be used in each and every method of correlation. Okay. Now formula number 6 is most important. 6th number. This is called shortcut method. Sorry. Shortcut method. Or this is also known as a method of assumed mean. This formula is used only when x bar and y bar or x bar or y bar are in fraction or observations of x and y are very large. Okay, so when we have to use this formula when x bar and y bar are in fraction, means point માં હોય, or x bar is in fraction or y bar is in fraction. એટલે કે x bar y bar બંને fraction માં હોય, અથવા x bar એક જ fraction માં હોય, અથવા y bar fraction માં હોય, કે x અને y ના observations ખૂબ મોટા હોય, ત્યારે આનો યુઝ કરશું. r equals to r is equals to n sigma uv minus sigma u into sigma v upon under root of n sigma u square minus sigma u whole square into under root n sigma v square minus sigma v whole square. Okay, where u is equals to x minus a or u is equals to x minus a upon cx. V is equals to y minus b or v is equals to y minus b upon cy, where a is equals to assumed mean for x and b is equals to assumed mean for y. Cx is equals to common factor of x and cy is equals to common factor of y. This is most important formula of Karl Pearson's method. Okay, 7 number. Now we are going to write last formula of Karl Pearson's method. Formula number 7. Wait. Yes. This is 7 number. This is called formula of two-way frequency parallel. R is equals to, આ જે ઉપર આપણે ફોર્મ્યુલા જોઈ હતી એ જ ફોર્મ્યુલા છે, એમાં ખાલી F લગાવવાનો છે, આપણે બીજું કશું નથી. ટુ વે, ધીસ ઇઝ ન્યૂ ફોર્મ્યુલા ફોર યુ. તમે 12th માં શીખ્યા એના કરતાં એક આ નવી ફોર્મ્યુલા આવશે. R is equals to N sigma FUB minus sigma FU into sigma FV upon under root of same formula but multiply with F in under root N sigma FU square minus sigma FU whole square into under root N sigma FV square minus sigma FV whole square. Okay, and where F is equals to frequency. Okay, now formula of Karl Pearson's method are completed here. Now we are going to write formula of Spearman's method. Method number 2 એમ પણ કહી શકીએ. Method 2. Spearman's rank correlation coefficient. Spearman's rank correlation coefficient. There are two formulas in Spearman's method. Number 1 is regular formula. R is equals to 1 minus 6 sigma d square upon n into n square minus 1. Okay, where d is equals to Rx minus Ry, and R is equal to rank of X, and Ry is equals to rank of Y. Okay, now formula number 2 and last formula of this chapter. When observation of X or Y is repeated for 2 or more times, okay, then R is equals to 1 minus 6 into bracket sigma d square plus Cf upon n of n square minus 1. Okay, where Cf is called correction factor. Cf is equals to n cube minus n upon 12, and m is equals to number of times observation is repeated. Okay, So these are our formulas of Karl Pearson's correlation coefficient. Okay. Now in next lecture we will start our sums of Karl Pearson's method.